Welcome to Talk Without Borders. I'm your host, John Petit. In this first episode, I had the pleasure of talking to Dr. Patrick Glauner. Dr. Glauner is one of Europe's most prominent academic leaders and experts in the fields of artificial intelligence. He advocates for promoting the large-scale adoption of AI and is an outspoken proponent of adapting ethical and responsible AI. We talked about important issues such as defining AI, the rise of ChatGPT, the economic and social implications of the EU AI Act, the benefits and challenges of adapting artificial intelligence on a larger scale, and the potential risk of implementing artificial intelligence into every aspect of our lives. Before jumping into the conversation, I want to share a little bit about why I decided to start this podcast. I've always believed in the power of meaningful conversations. The podcast medium offers the freedom to engage in long-form conversations, explore ideas, hear different perspectives, and dig into intriguing stories and narratives. With Talk Without Borders, I want to create a space for those conversations. I will be talking to leaders and influential figures in business, politics, entertainment, and society, starting with a focus on Luxembourg and the European Union. But who knows, maybe one day I'll venture across the Atlantic to include voices from the US and beyond. I'm excited to share these conversations with you, and I hope they leave you informed, curious, and more knowledgeable. And now, without further ado, I give you Patrick Glauner. Hello, Dr. Patrick Glauner. Welcome to my podcast, my first guest, of course, so very honored to have you on. Welcome to joining me today.
Hi, thanks for having me on the show.
Just to list a few of your credentials, so you are a professor of artificial intelligence at the Deggendorf Institute of Technology, which is in Bavaria. And then you previously were a fellow at the CERN Institute. You advise regularly European, state, and local politicians on AI matters, innovation. You're a published author, 5 books have appeared in many different journals. You have your own consulting company, Skyrocket AI, where you help companies and executives implement strategies to integrate AI. So my question would be, you're definitely not busy enough, it seems, from your bio.
Well, I like working. I think that's most important. You know, some people, they work to live, but I live to work because I was able to turn my hobby into my career so I can do all day long cool stuff. And that's what I'm enjoying. So it doesn't feel like an obligation. Rather, I get better and better every day by doing cool stuff. Yeah, and I don't work 100 hours per week anymore. I did that during my PhD. But now that I have my wife and my kids, maybe it's 60 to 70 hours per week, which is still lots of work and it's fun, but it doesn't feel like exhausting. But I also need some time, obviously, for my family.
Where does that work ethic come from? Is that something that you learned along the way, or is that something that you've always had?
Well, I got interested in programming and algorithms when I was in high school and just found it super cool. And then once I could go to university, I could focus all day long on this. So I didn't need to go to high school anymore, where I had all these different subjects that I didn't like, just I could study computer science and just learn this cool stuff all day long. And then obviously later did a PhD, worked in industry, and now as a professor, I simply don't have a boss. I can set the strategy of what I want to explore, and I'm just working very hard on all of this, and it's fun. So the work ethic, it's just fun what I'm doing,
How did you, because obviously today we're here to talk about artificial intelligence. How did you get into artificial intelligence, or so to speak, what was it? Or did you have a watershed moment? Was it something that happened accidentally? So how did you get into AI?
Well, it happened at the end of my undergrad. So at my undergrad, obviously, I dealt a lot with algorithms, coding. I also liked computer engineering a lot. I liked SAP systems. I liked embedded. But there were no courses on AI in my undergrad. There was a robotics course and a computer vision course, but none of that was linked to learning or anything like this. For example, I did an internship at SAP during my undergrad. I worked on data problems, but not on learning. It was about preparing data sets for M&As and which transactions to run first in such a big update of the database. But obviously dealt a lot with data and big data. And then at the end of my undergrad, I went to CERN, the European Organization for Nuclear Research, for my bachelor thesis. And the application there was sort of a mystery because you could not apply to a specific position or a specific project. You could only apply to a pool. So I mentioned all the stuff I was doing, SAP systems, computer engineering, algorithms, and all of this embedded. And I thought I would get picked for something like this. And then I was picked by the team that builds CERN's digital repository. So a digital library for all the documents at CERN, not just papers, photos, videos, internal documents, lots of stuff. And I was supposed to work on the search engine. And I thought, well, I didn't do that kind of stuff before. And I was pretty surprised to get picked for that project from the pool because none of the skills required really matched what I was doing before. And I didn't do Python before, and the team worked in Python, but I before worked a lot with Java, C++, ABAP. But the team leader picked me because he felt from my CV I was able to adapt to all of this quickly. And then I worked on search engine problems and how to improve the search engine and the search result quality. And for that, I got into the natural language processing and machine learning. And pretty much at the same time, when I started there, we saw that Stanford professors made their courses publicly available to everyone, like Andrew Ng. So this was in late 2011,
I was
early
going to ask.
2012.
I was going to ask what time period that. So was that in the beginning stages of when in the developments around AI took off?
Yeah, so this was in late 2011, early 2012 when I started at CERN, and then Andrew Ng made his machine learning course publicly available, and this eventually later led to Coursera. There was Sebastian Thrun, and he and Peter Nurvik, they made an AI course, and Sebastian Thrun came from Stanford, and this led to Udacity, and there were some other courses. And I just found this very interesting and thought, well, I'm working on, data problems at CERN during my thesis. Maybe I could learn something new from these courses. And I just got super impressed from that. And then I finished my undergrad, stayed on at CERN as a fellow. And then later I felt I wanted to learn this stuff, not just from a practical perspective, but also more from a theoretical perspective. Was very fortunate that Imperial College offered a master's in machine learning, which I did then. And then later I did my PhD and all the other stuff around AI. So I've been now in AI full-time for more than 13 years. And it actually somehow goes back just to that I was picked from this pool of applicants at CERN into a team I had never expected. So each time when I'm at CERN, I sit together with my former boss, and each time I thank him, he picked me, not just because I started working at CERN, but that this is how I got into data and AI. And when I met Andrew Ng earlier this year, so I was in Davos at the annual meeting, I met Andrew, and I also told him, thanks to your course from Stanford that you put online, I got super interested in AI, and without this, I may have not made an AI career. So I felt I should have said this to him when I met him in Davos, and he also looked happy that someone benefited that much. But there were obviously millions of people who took that course.
Essentially, if I recap this correctly, you didn't plan out to go into an AI career, but during your time at CERN, that's when you discovered, oh, this fits my profile, it fits my qualifications and my skills, and this is something I can excel in.
Yes, it happened at the end of the undergrad when I was at CERN, and I saw a lot of potential in that, obviously, and felt there would be a great future for AI. And I'm just very happy that it's all worked out. Had I, say, if a CERN team in, embedded or SAP systems had picked me, I would have ended up there and maybe never got into the AI direction. I don't know. Plus the timing with the courses from Stanford that went online, that was a very good coincidence and further sparked my interest in all of this.
So as you said, you've now been active for 13 years in the field of AI, if I understood this correctly. So I'm going to ask you a very easy question, of course, to get into the topic. What is AI?
Well, there is not that single definition of AI, and that's certainly a problem. It confuses a lot of people. In one sentence, AI means to me, it's about automating human decision making. So humans make up to 30,000 decisions per day, certain studies say, in private as well as professional life. And with AI, we aim to make these decisions faster, cheaper, and better. And there are different directions like expert systems, machine learning, and so forth. That's my view. If you ask some other AI professor or some other AI practitioner, I can guarantee you they'll tell you something totally different.
I think it's a very interesting point that, like you said, if you ask different people about their definition, they might focus on completely different things. Like for you, it's the automated process that's very important, right? So the automation of processes. Others might look more at the ethical part. And then others, again, might use like other factors. So it seems to me, do you think that we need a better framework or definition for what AI is? Or do you like that it is that vague for a lot of people, that then pick and choose certain aspects of it? Do you think there needs to be a broader definition? What's your point on that?
It is very vague because it overlaps with a lot of other fields like statistics, logics, and lots of other subjects or signal processing. And that makes it so difficult to delimitate from other subjects. And there are all these different definitions. For example, there's this very famous AI book, AI, A Modern Approach, authored by Stuart Russell and Peter Norvig. I mentioned Peter Norvig before, but Stuart Russell is the other author. And I met him twice this year in Davos and also at a conference in South Korea, and asked him, look, you have this probably the most famous AI textbook, but you don't have that definition. And then why don't you put one in? And he said, yeah, well, if we attempted to define it, probably we would just get a lot of criticism. And then I said, well, maybe for your next edition of your book, don't try your own definition, rather collect definitions of others and analyze and compare them. Maybe that could be a good start, because it is obviously awfully difficult for others to grasp what we are doing if we are unable to define our field, what we actually work on. And I think that's super confusing to politicians, managers, and others, and a problem. But I don't think there will be that definition suddenly, because, as I said, the field intersects with lots of other disciplines.
Yeah, and I think what you should mention also the lay people, right? So the people that they're not as technical, that don't have this technical affinity, maybe, that might not understand it. So it might be a little bit confusing for them. But maybe let's break down a little bit, what different parts of AI there are right now, right? So I think pretty big right now, and so I don't know if you call it maybe task-oriented AI is what we have right now, right? So if I understand that correctly, for the most part, what AI can do right now is it can do a very specific part, large language model, an example, right? So very task-oriented, but there's different types of AI in this task-oriented approach.
I think what you mean by task-oriented is a term I don't use, but what you maybe mean is a narrow AI.
Sure, yeah.
Very specific tasks and does very well in those, but it doesn't do anything else. The LLMs that you mentioned, they are again special because they are maybe a little bit broader. But yeah, we are largely working on very narrow AIs that an AI can do some specific task like recognizing defects in a production process extremely well, better than humans, but only that. But the beauty is if we use machine learning to build all of these approaches, in machine learning, we have very generic models. Obviously, they have to be trained for each task, but how they work is largely generic, like things like a decision tree learning or logistic regression or a neural network. And these models are super generic and can be applied to lots of things. But now I mentioned machine learning. So what is that? What does machine learning mean to you then? How would you define machine learning?
So for my understanding, machine learning is basically, so the way, for example, LLMs work is you have developers, they feed the LLM with data, And then machine learning is basically the process of the software that go and collect these data and learning by themselves, creating rules for improving their knowledge on a specific topic of whatever that software does, right? So basically, it creates these neural networks, and similar to the brain in a way, and then it basically learns similar to the human brain. It learns and accumulates this information by crawling all the different spaces of data, and then learning and getting better by repeating the same process. That's my understanding. I don't think it's quite accurate, but that's my basic understanding of machine learning.
I'll say a few words on this. So one direction that is not machine learning would be an expert system, meaning we talk to experts and we try to formalize how they make decisions and turn this into rules and implement them. Mm-hmm. And this works for certain problems, but for a lot of problems, it doesn't work very well because of the huge complexity of domains and so forth. So the other approach is machine learning, that I don't describe these rules, but rather I take examples, so a data set, and present it to an algorithm to find some pattern in it. And that's machine learning. And then most machine learning models, they use statistics, not all of them, but most use statistics. And they would find some pattern in the data set. And we find this pattern. And eventually, in many cases, the pattern could also be just seen as a set of rules, but we're not describing it. Rather, we find it statistically. And there are hundreds of different machine learning models. And one direction are artificial neural networks, which have been hyped a lot in the last few years. They're helpful nonetheless. And they are also the basis of large language models.
I think I read that, and I think it might be an interesting fact for the listener to know, is actually how expensive it is for let's take these large language models, because they have to buy all the storage, right? That's like an enormous amount of space that they need, and electricity. That's why often I think just this process of machine learning and training these data sets, that's often costs hundreds of millions of dollars, right?
Maybe for the high-end large language models.
Yeah, but
But there are lots of other machine learning approaches for other problems, and you can just train them on your smartphone or your laptop, and it doesn't need millions of euros for the electricity. It largely depends on the model, but these large neural networks, we try to build ever larger neural networks for which we need ever more data, and they are helpful for certain things like question answering or summarizing texts, but they are often misused for very simple tasks, like just classifying a text into a certain class. For this, you can use traditional machine learning methods that work extremely well, and you don't need large language models just to classify text, because it's way too expensive. But you can do this far simpler with other approaches.
So what do you mean by traditional machine learning process versus the more modern large language models?
So as I said, there are hundreds of directions in machine learning. So for example, there are other things like decision trees, naive Bayes. So naive Bayes is something that builds on Bayesian statistics. And this kind of stuff like naive Bayes can be used super well for classifying text. And these are models you can just train on your laptop, and you can do the inference super easy. For this, you don't need a deep neural network. So people now use these large language models that are based on deep neural networks for sometimes super trivial tasks, and we're just running out of electricity. And these neural networks, they're not necessarily doing better than the other approaches. They do better on certain tasks, but they are not more powerful in general.
But I think they're certainly more popular right now, right? So, for example, I'm just going to use ChatGPT. Of course, there's others, right? Right now, you have Gemini, which is obviously by Google right now, and you have Claude. And so there's like a whole bunch of LLMs that are proliferating right now. For example, ChatGPT, just 2 months after launch, 100 million active users. I think the fastest growing consumer application in history. So what do you credit this enormous, I don't know if success, but just popularity of these large language models?
I find this terrific because it also helped to popularize AI, because when I started my professorship nearly 5 years ago, I cared a lot about science communication and making all of this more accessible to the larger audience. But the media struggled to report on this, because if you say I have a neural network that finds some pattern using statistics, this isn't that
Sure.
cool that a newspaper
It's
would
not that
report on.
sexy. Yeah. Yeah.
Yeah, and you cannot really
Yeah.
visualize it.
Mhm.
So now with ChatGPT, it's something people can easily use. It's obviously just a tiny part of AI, but at least it helps people to somehow interact with it and work with an AI, that they know it is an AI. So it helped to massively popularize the topic and has led to this huge boom of AI companies, AI applications. Certainly very helpful.
What would you say areas right now of AI that are most promising from your perspective? Is it healthcare? Is it the industry? So where do you see your most potential for AI?
Yeah, obviously, I see potential in nearly every industry. Healthcare is particularly interesting, and that has to do with the fact that because of demographic change in Europe, we have an aging and shrinking population. So we need to massively scale healthcare while we actually have less and less doctors available. That's the reality in, say, Central Europe. It's also a reality in China, for example. So this is shared by other parts of the world as well. And so we need to massively scale healthcare. And for this, AI can be part of the solution, because it will not happen that we suddenly are able to train millions of additional doctors that we cannot pay for, but we need more automation. And here AI can help, so people can actually still get treatment probably better and quicker than right now. So it's a massive opportunity. But you can apply AI to other industries as well, like autonomous driving is important. Does this make taxi drivers unemployed? Well, not too much. Right now, there's a huge lack of taxi drivers in Europe. And so again, here we need more automation, and jobs change. For example, the job of a taxi driver will change, maybe not necessarily driving a car anymore, but maybe helping elderly to enter the car, help people to carry their groceries upstairs, or help them to carry some suitcase. This is something the autonomous car is unable to do at present time. So this is where the human can actually help. But I also work a lot on applications in mechanical engineering, in power engineering, which, for example, the smart grid is key for our energy transition, more going towards solar and others. For this, we need a smart grid, and AI can help here. So there are lots of industries, and I'm just super excited to see new AI applications every day.
So you mentioned a scaling process in healthcare is very important. So how would that look like in practice? So what would this scaling process look like?
Yeah, so maybe you're at home and I mean, there are apps for this already, and you have maybe some skin problem, but you don't want to go to the doctor, you're unable to go, but maybe you can take a photo, and then an app could assess whether that's serious or not. And if it's serious, you will get an appointment with your doctor, maybe even quicker. But if it's not serious, you don't need to go there, And here the AI can help. And if the app is not sure, then obviously a domain expert could be included at that stage. So that's one example, and such apps have been available now for the last few years. Or, I don't know, look into hospitals. Nurses, they waste a lot of time moving around people in beds. They move these beds from room to room or to the surgery room. Why don't we use autonomous hospital beds, so people can actually focus on doing their actual work, and they don't need to push beds around. Or lab analysis can be done maybe much quicker, or you even find disease much earlier than humans find them. So all of these are examples of how AI can help us to skyrocket and scale healthcare.
Part of your philosophy, I think, is AI should not replace the human, right? I think this goes in line, but it should help the human accomplish tasks, right? Is that a correct phrasing of your mindset?
Yes, it should help us, but obviously some people will be put out of business. That's sure. But this has happened ever since humans work on technology, that jobs come and jobs disappear. And if today you just look back 100 years ago, almost no jobs from that time still exist today. So education and training is key. But and AI, yes, AIs will put people out of business, but largely the AIs will put those people out of business that are refusing to integrate AI in their work. So even a coder, a software developer, will not be fully replaced by an AI anytime soon. And there are also theoretical limitations for this. But if an AI helps a coder to become 30% more productive, then those who don't use AI are the ones who are going to be out of business. Because if your colleague, just your friendly colleague next door, 30% more productive, you will have big problems in justifying your pay. You will probably not be promoted, and you will probably be replaced sooner or later. So you should think about how you can integrate AI in your workflow to become more productive.
So you're basically saying that going down the line or the future, people that are unwilling to engage with AI will have a disadvantage versus people that are willing to engage with AI.
Absolutely.
How do you see people that are more on the negative side? I would assume you encounter these types of opinions very often that focus more on the negative parts. So let's say they say, oh, well, we think that AI is going to replace people. It's going to negatively affect people, their future, their work life. So how do you engage with these kinds of opinions?
Well, there are obviously risks around AI that need to be managed, and we need to ask ourselves which processes should be fully autonomously decided, or where should the AI support a human, or where do we need human review. All of that needs to be discussed individually in the use case. And yes, AIs will kill people, like an autonomous car will kill people. It has happened already. But if you look at like per billion kilometers driven, much less people get damaged from autonomous cars than from human drivers. And that's a huge opportunity if we can reduce the number of accidents in traffic, and we can reduce them massively because of autonomous driving. And yes, there will still be exceptional cases where people get damaged, but far less. And I think that's a huge opportunity. Plus, it's not always necessarily the car's fault, but sometimes it's just, if a human suddenly crosses a red traffic light while cars drive there, it's an issue. And I just saw a video a few days ago of an elderly man who walked on the sidewalk and just fell on the road, but it was an autonomous car and it directly diverted and drove in the opposite lane. It bumped into a car that was there, but two cars got damaged. But this person who fell from the sidewalk on the road actually survived. And with a human driver, this would have not happened.
I think you're absolutely right. I think AI can solve so many problems and can do certain tasks much more effective and better than humans. But let's just say, is there in your mind, is there a chance that we will lose, or that there is a risk that we will lose control over the AI? Meaning, if you have, hypothetically, let's say you have malicious people or people with bad intents, and they get behind the engineering of these AI systems, could this not be negative? So I want to give, just before you answer, I want to give an example. Max Tegmark, famous AI researcher, and he said, I think, quote, AI could be either the best or the worst thing ever happened to humanity. Now, this is obviously a very polarizing statement, but obviously what he meant to say is that it's either going to be really good or it's either going to be really bad. So what is your stance on that?
Well, eventually it's a tool, and it's up to us as humans how we use the tool. You can use a knife to cut your steak, or you can use a knife to hurt someone. You can even hurt someone with a spoon, by the way. But that's why we don't ban spoons, or we're concerned that spoons take all over the world. I mean, eventually, AI, these are algorithms, and we have embedded algorithms into our daily lives for the last 50 or 60 years, and it's not like that this resulted in the apocalypse. And now, because maybe these algorithms are a little bit smarter or they find patterns in data, that doesn't mean that the apocalypse is anywhere near. And yes, you can use tools to someone's disadvantage. And this is obviously where legislators come into play. But we'll anyway talk a lot about regulation later, I think.
Yeah,
So
let's not jump ahead. I was going because you have very strong feelings about that
but
too.
there are ways to control this, and also we have knives out there. That doesn't mean everyone steps everyone,
I want to pick up that example with the knife. I think it's interesting. What I would say is a knife is not as a complicated system as AI, which you might speculate could become self-conscious at some point. So then it would no longer be our decision, right? I think that's the point that the skeptics are making, is that what if at some point we are no longer controlling what this tool, as you described it, is doing, but this tool is just outsmarting us and outperforming us in every way possible.
Yeah. Well, for example, today, these deep learning architectures, they can largely be described by linear algebra operations like matrix multiplications, plus a few other things. But I don't think that, matrix multiplication suddenly become conscious and take over the world. Obviously, we don't know what could happen in 500 years. We just don't know. But could we right now productively prevent this from happening? And I don't think so, because this is just too far away to prevent it, because we would first have to make a lot of preliminary steps. For example, I mentioned Andrew Ng before. He provided a very good comparison, maybe like 8 or 10 years ago, about this. And he was asked how he's actually stopping this from happening. And he compared this to space. He said, right now, engineers are working on sending humans to Mars. So are AI engineers working on the next big thing in AI. Some are even thinking about how to maybe colonize Mars. And so we are thinking about far more steps in AI, but no one right now is actively working on preventing overpopulation on Mars from happening, because it's just too far away. There are too many preliminary steps you would need to take. So you cannot productively avoid this right now. And so he says this also about an AI. Yes, maybe one day it becomes conscious and just keeps growing and growing, and it leads to the apocalypse. But right now it's just too far away from productively preventing this, because we first need to make a lot of other steps before we're even near to that scenario.
So you're saying that right now we should focus on pushing this as much as possible. And then at some point, if we're faced with general artificial intelligence, maybe you can explain this concept also in this context, then we should worry about it. Is that what you're saying?
Well, obviously, we need education and we need to use these things responsibly. But education is key to understand how AI works, how we can integrate it, how to use it responsibly. And we have far more pressing issues like demographic change, shrinking population, high energy costs, where AI can help to address all of this. And we should focus on this and not on hypothetical scenarios that are just too far away. Now, you had mentioned artificial general intelligence. What's that? We had before talked about very narrow AIs. And now one could think we built a very broad AI that could actually, do a lot of tasks, or all tasks humans can do, better than humans. Something like this would be called an artificial general intelligence, and the point in time when this is reached is often referred to as the technological singularity. When would this happen? There are different predictions. There is like a book from Ray Kurzweil. It says it would happen by the end of the decade. I don't think we're anywhere near to this. I think it's just super far away, because there are a lot of preliminary steps to take, and just building ever larger neural networks with more data doesn't help to get us anywhere near that. And that is largely understood now by AI experts. So we would have to rethink probably a lot of computer science from scratch to get anywhere near that. And that's just too far away. There are also people who say this could never happen. Probably, you should never say always or never, whatever like this. Obviously, it could happen. There's a very good book. It's called The Technological Singularity, written by Murray Shanahan. It appeared, I think, in 2015 or so with MIT Press. He was one of my professors at Imperial College and gave a terrific lecture on AI that I attended on computational neurodynamics. And he does not provide his own prediction in a book, but rather collects predictions of others and assesses how likely they are and what consequences could be if that prediction becomes true. And I think that's a very smart choice rather than trying to, make your own prediction. So I can just invite everyone to buy Murray Shanahan's book. It's a great read.
Yeah, and I think that's right. There's so many different perspectives. You have some people that see this as becoming, really bad, really fast. Others say it will never happen. Others are a little more measured. So yeah, I think there's a high diversity of opinion.
So there was just, with the Swiss television, an interview with Mr. Harari, who is one of these skepticals around AI.
I saw that interview. I saw that on the LinkedIn.
I posted about it on LinkedIn, and I said something like in German, like it's if blind people talk about colors, because I don't see anything in his career which actually, or in his vita, which, credibly refers to AI. He's a professor of history, I think. And, but he's now often cited as an AI expert, and I just really don't know why. Obviously, AI needs to be interdisciplinary. We need to bring together a lot of people, but at least you should be knowing what you're talking about. And I say, well, we've been, mass embodied AI in our daily lives for the last at least 20 years, in all sorts of applications, or even longer if you include some methods that come originally from signal processing. And the world has not ended. And I don't think it will just suddenly end in the next 2 years because of AI.
Now, I think I understand where you're coming from. Obviously, you have spent a lot of time reading about this, learning, teaching, and I think this person is probably coming from a perspective of, like, we talked about it in the beginning, different people define AI differently, right? And so he probably looks at it from a lens of ethical understanding, but he obviously doesn't have the same understanding as you do. So I think it's fair to point out that you have a little more basic knowledge than he has. But I want to jump to the competitiveness, or the level of competitiveness in the United States versus Europe. Maybe we can even throw in China. So where do we stand right now? And I think you have a very clear stand here and say that we're lagging behind the United States, which I think could probably be perceived as the leader in AI right now.
Well, I just published an index report about the global AI competitiveness. Maybe you want to link this with the podcast, because I've just posted about it on LinkedIn. What is that index? There is an organization based in China. It's called the International Finance Forum, or in short, IFF. Mm-hmm. They are something like the World Economic Forum, but focused more on finance and emerging markets. And they had their annual meeting in Hong Kong last weekend, from which I just returned yesterday. And what we want to do is we want to provide an AI competitiveness index. And there are 5 directions we're looking at. One is enterprises, then R&D, human capital, policy and regulatory environment. And the last point is market acceptance and infrastructure. And our first report looked at enterprises. And we saw that something like 36% of all AI enterprises are based in the US. So there are something like 55,000 AI companies in the world. Companies that are either fully focused around AI or established companies that have started to build AI. And obviously, it depends a lot on the data sources, but we've worked with the Deep Knowledge Group that has provided terrific data, and we've looked at other data sets as well. And we saw there are like 55,000 AI companies around the world. 36%, or more than 20,000, are in the US. So US is massive because if the historic ties to AI, because there was the Dartmouth conference in '56, and you have the Silicon Valley and so forth. And then there are other countries in the top 10. So number 2 in terms of the total number of companies, actually India, then the UK, Japan, Canada, mainland China, Germany 7th. Again, it depends. The exact magnitude or the exact numbers depend a lot on the data sources, but it's something that we see relatively. And the US is far ahead. China is working very, very hard and spending a lot and creating lots of innovation, also lots of patents now. And if you look, for example, at the density of AI companies, you can see Hong Kong is extremely strong, or for example, Singapore. So the United Arab Emirates are starting to invest massively in in AI. So there are super interesting things happening around the world. And what we should see in Europe is most of that is happening outside the EU right now. And there is a number of reasons for this. We are often very driven by fear and risks in the EU, while maybe the US or China or United Arab Emirates are more driven by opportunity. Funding for startups is a challenge in the EU. So venture capital is an issue. And we also try to add always more and more regulation in the EU. I'm not super negative about the EU because there's huge potential, because we have actually very good education. We have lots of data in industry that we can leverage. So there's a lot of opportunities and a lot is happening. But obviously, more things are happening all around the world. And this is something that should wake up people, because, for example, if you look at healthcare or engineering, say mechanical engineering or chemistry, a lot of these processes that are described by domain experts, they have pretty much converged. Domain experts are really challenging to further describe certain properties in chemistry or in mechanical engineering. But using AI or machine learning, you can find hidden patterns in data using statistics. And like this, you can skyrocket chemistry, you can skyrocket mechanical engineering. And if this happens outside the EU, so that if progress in chemistry or engineering or healthcare is made outside the EU, this would mean that we become even more dependent. And that's what I don't want to happen.
Do you think there's a culture problem in Europe compared to the US, for example, in terms of, let's say, are we, like you said, we're afraid to innovate, we tend to regulate more. So do you think that's a mentality that's more prevalent in Europe, or is it another reason?
It's something that has become more prevalent in the last few decades. It was certainly not always this way. I mean, for example, after World War II, the center of the continent had to be rebuilt very quickly, and people were not worried about thousands of pages of regulation, how you could build a building or a bridge, but things had to get done. Obviously, regulation is important, so we have safe processes and products. But if we're only driven by fear, say we don't build a bridge because it could collapse, that's a problem, So we rather build a bridge and try to build it efficiently and safe, rather than worrying for decades whether the bridge could collapse and thus not building it. And China speed is a term that is often used, that China, as well as other countries, move ahead super fast. And at some point, we will really struggle to catch up with this. If economic realities follow, meaning that, for example, certain countries like the United Arab Emirates, they aim for the next few decades that they can generate like 40% of their GDP using AI. This will also mean that the worldwide power is shifted. And then we even have less to say when it comes to market standards, when it comes to regulation, international standards. So we should be at the forefront of innovation and deployment.
Obviously, you talk to a lot of people in the field of AI, both in the US and both in Europe, let's say Germany, Switzerland, Austria, or any neighboring countries. Do you actually see this difference in how the people in different countries perceive AI and the level of risk they're willing to engage? Is that something that you notice? For example, if you talk to someone in the Silicon Valley and you talk to someone in Germany? Is there a difference in how they
Well,
approach it?
obviously, comparing Silicon Valley to some random place in Germany is probably difficult. Similar, it would be difficult to compare Berlin to some rural village in the US. But I think in average, in the US, people are more driven by opportunity to capitalize things, to innovate. And the same in China or the United Arab Emirates, for example. Obviously, they think about risks, but they are not risk first, but opportunity first. And that's a huge difference. And it was different in Europe as well. And it's still, I don't know, if you look at the UK, maybe they're a little bit more open to innovation and less to risks. But it's really an issue now in Central Europe. If you look at Eastern Europe, like the Baltic states, they're also very open to digital innovation, Luxembourg as well, obviously, is very open to innovation, where I was based. But Germany, France, Italy, and the other big players, they certainly need to do more.
Talking about the EU AI Act, and I think how much do you dislike the EU AI Act? Maybe you can first explain what the EU AI Act is, what it entails, and spoiler, why you don't like it.
Well, the AI Act is a horizontal regulatory framework. It means AI for everything, meaning every AI use case would be regulated by such a horizontal framework. Why was it proposed? The European Commission proposed it 3.5 years ago, saying that AI was totally unregulated, there was a legal vacuum, and they would need to close it. Personally, I disagree about the legal vacuum claim, because if regulation is important, and we have lots of vertical regulation, for example, regulation for cars, for airplanes, but also for financial products. And vertical regulation means it addresses that use case or that domain, and there are requirements for a system or a process. But how you build that system or process exactly is secondary, because you just have these general requirements for that system or that process. Now, if you put AI in such a system or process, obviously your AI needs to comply with this vertical regulation. And that's why I doubt the action. Sorry?
Could you give an example of what a vertical regulation would look like? Maybe?
For example, safety standards of a car, and you put AI in your car, obviously the AI needs to comply. Or for nuclear power plants, we've been using AI systems to control nuclear power plants since at least the 1980s. Mm-hmm. And the AI had not caused Chernobyl. Probably the issue in Chernobyl was that it was done by humans, and they didn't have the AI that could have prevented what happened, And if you put AI in such a system for which your vertical regulation, your AI needs to comply. So I doubt if there's actually a need for the AI Act as such, because if you horizontally regulate AI in addition to your existing vertical regulation, this leads to duplicate regulation, leads to contradictory regulation, and it just makes R&D and deployment far more expensive. Maybe it will suppress innovation. None of that is something we want. However, I think the AI Act may have a good intention, but the first draft was 120 pages, the final version was something like 400 pages after 3 years of discussion in Brussels. I think it has a good intention, but maybe you can write down this good intention on 10 pages, which actually still makes it understandable and enforceable. Because if you have hundreds of pages of regulation that no one understands, this does not help to increase certainty. Rather, it increases uncertainty, and that's not great.
So in reality, when, let's say, I open my own company, I'm an entrepreneur and I have some sort of AI software and I want to open my headquarters in Europe. So how would that affect me specifically? Could you give an example?
Well, every company that uses or develops AI needs to comply with the AI Act. And first of all, how does the AI Act define AI? We need a legal definition. That one is unfortunately very broad and no one really knows what it covers. possibly much more than actual AI. But the AI Act was just ratified in the summer, and step by step over the next few years, some parts of it will become active. And eventually, courts or comment literature will sort of help to shape this, as well as industry standards. And then, for every AI use case that you have, you need to do a risk assessment. So there are two categories of lower risk, then high risk, and forbidden. And forbidden is forbidden, but I wouldn't ban specific practices related to AI. I would ban that practice in total. For example, the AI Act bans that you do social scoring through an AI. Social scoring by government, not by industry, because there are good use cases for social scoring by industry. But obviously, I don't want social scoring by government, but I would ban this totally, and not just related to AI, because if humans or some other system does social scoring for government, then it's allowed. So I would ban it entirely. And there are also high risk use cases, and high risk, you would think that these are the use cases that threaten human life or health and safety or your financial assets. And for those, you need to comply with very, very high requirements. But high risk in the AI Act is more than just high risk. As I described, even AI in education and sometimes trivial things are suddenly high risk too, and come with very high standards that are difficult to comply with.
So you're saying that the category is too broad when in terms
Exactly.
of how the AI Act defines high risk categories. You say that is too broad, and there are companies and there are things in there that are actually not high risk.
Exactly. And this risk classification is one of the challenges. There was a study a while back from a company. They looked at 100 use cases, and almost half of them they were even not able to adequately classify. And this again adds uncertainty. And this happens if you write ever longer laws, hundreds of pages, and no one knows what it means. As I said, there may have been a good intention, but you could write this down on 10 pages and probably solve a lot of issues.
So in a way, I think, from my understanding, the AI Act came into being because of the privacy issue, right, or data confidentiality. I feel like that's the main concern that not opponents of AI, but let's say skeptics or people that want to regulate it have. They would bring up this point of data confidentiality, right?
Well, data privacy is again different laws like the GDPR and so forth. So it's not necessarily part of the AI Act, but obviously your AI needs to comply with data privacy laws.
Where do you see Europe in 5 to 10 years? Do you think they will be able to close the gap to the US or China, or do you think we'll keep lagging behind as time goes on?
Well, with the AI Act, the risk is that lag or that divide gets even worse. Because if we make AI R&D most expensive, this will not help us. Now, companies need to find good solutions to the AI Act. And for example, industry associations, they are working on writing checklists. So maybe that SME can just go through a checklist of 2 or 3 pages and then see whether they are probably compliant or not. This is easier than going through 400 pages. But another issue is the enormous electricity costs in Central Europe. And now if you want to build these very large neural networks, you need a lot of electricity. And in the US or China, it's just far cheaper than here. And this will probably contribute to the divide even more.
Looking ahead into the future, how do you see AI impacting society, especially as it gets integrated into daily life more and more? Maybe, or are you saying we can't really predict what it's going to look like? Or maybe you can even say, what would be your ideal for what it should look like in 5, 10, 15 years?
Well, we will see far more AI applications in our daily life. Already today, we use AI hundreds of times a day without explicitly knowing it, but it's embedded in a lot of applications. This will go far up, so we can have maybe a healthier, happier, and longer and better life. Maybe we can have more help with in healthcare. We can have also a more sustainable industry because we can use resources more efficiently thanks to AI. So maybe we need less acid or whatever in the cleansing process. All of this is helpful. We can improve transportation. We'll have more autonomous driving. So you as a parent, you don't need to always drive your kids around. Maybe your car can do this on its own. Or elderly people can be transported autonomously. So there are lots of opportunities, and I'm working every day on making this come true as a professor, as well as in consulting and political advisory. But I wish we were not always just leading in regulation in the EU, but rather in innovation. And we should also reinterpret the term regulation, because it always means only bans and constraints to us. If you go to China or the US, it also means how to foster innovation, how to invest in these topics, because the government can also see that on its agenda. So the term regulation should be interpreted also from a more positive side and not just from a negative side.
Do you see in terms of what types of jobs will be created? Obviously, you talked a bit about the job displacement earlier. So how do you see the progression? Because I think obviously first you have the more low-skill jobs that are going to be replaced, and then you're going to move to, more educated professions, let's say lawyers, doctors, academic people, So how do you see this happening? How will AI fuse with these higher skill jobs, not only necessarily lower skill jobs?
Well, the AI primarily targets the white collar workers, because the blue collar workers have already been massively disrupted by, industrial automation. So this time it's about lawyers, doctors, even software developers. But it doesn't mean that they all become unemployed. Rather, they should use AI to become better. And again, in Central Europe, in times of an aging population and shrinking population, in times of a lack of talent, mass unemployment by AI is really the thing not to worry about. There are far more relevant issues, and here AI can help us to address them. And yes, some people will be put out of business, but this has always happened, and you need to see how you can remain competitiveness, and for that, education is key. And that's why we also need more science communication. We need more training for broader parts of society, and all of this will help us to take advantage of AI.
What advice would you give people that are maybe either skeptical, or they don't quite understand how AI can affect their life or how it can improve their life? What would you tell people if what would be a good starting point?
Well, think about tasks or things that you don't like to do, and maybe an AI can help you to do that. Or elderly people, they need to write lots of paperwork, lots of letters they need to send to their health insurance provider. Maybe an AI can help you to speed up. So write down the tasks you don't like, and you can think about if an AI could help or not. Obviously, an AI is not magic. It will not suddenly make all bothering tasks go away, but maybe for some of them. And then you have time for other things. So I see this as a huge opportunity. And then get an education about AI. There are free online courses like Elements of AI, something that is now available in lots of different languages all over the world. Just provide you with a brief introduction to how AI works. And I think all of these are things you should do, and think about how you can remain competitive.
So before finishing the interview, there's another topic that I find very, very interesting, and I just want to look across the pond to the US for this. So we had the election, and obviously right now with social media, you have this misinformation, right? You have the fake news. That was already a problem in the US, right? And it has, I think, exasperated over the years. How do you think AI comes into this right now, right? And I think there's already some negative instances of the deep fakes, right? And those sorts of things that appear. So as there is already such a polarization in the political sphere and the social media spaces, how do you say AI, factoring into this equation, so to speak?
Well, fake news are a problem, and obviously AI can be used to generate fake news, but most fake news are actually made by humans, and fake news have been an issue in the media from the beginning on. And I don't think we saw this avalanche of fake AI or fake news generated by an AI in the US election as it was predicted. I think it was far less than what was predicted. And again, education is key to separate true from false. We could also be thinking about using an AI that can help us to classify or warn us if certain information is maybe not necessarily true, but for that you need a proper databases, and from that you can learn. And again, who collects data and assesses what's ultimately true, what's ultimately false. Hope this is not done by government, because we don't want like a ministry of truth or something like this. So these are some things we need to think about, but education is important. So you can actually think about whether some claim is rather true or rather false. And yeah, just turn on your brain. So human intelligence first, and then the artificial intelligence. But AI can help a lot in politics. And maybe, some parties have been exploring this to build chatbots. So you can get a you don't need to go to a local campaign stand of a party and talk to the politicians. Rather, maybe you can get some more personalized answers for your specific questions. I think all of this can be super helpful.
Oh, thank you, Dr. Glauner. This is very informative, interesting conversations. I think the audience can learn a lot from the different aspects. And I think, like you said, there's a lot of things that we still need to figure out about AI. I think right now we're in a good space where, like you said, innovation should lead our efforts in terms of what we can do with AI and how it can benefit us. But it's certainly interesting, I think, to see how this will develop in the ongoing years. And I'll be interested to see how you see this in a few years.
Perfect. Thank you for inviting me. And I wish all the listeners good luck for their own AI journey. And if you have any questions around AI, please get in touch.
Thank you so much.